Hey, we have here today another integral from the UNSW CPMS Integration Bee 2023. This was from round 2, problem 10. We have the integral of sine x over cosine x plus pi over 3 dx. Okay, now to get started with this, the problem I see is just the fact that we have different angles on the cosine and sine. And there's a couple ways I could see to deal with that. We could use the angle addition formula on cosine and split it up that way. Or what I want to do is do a u substitution, simplify the cosine, but then we're going to make the sine term more complicated. But I think it'll work out because then we can divide the cosine into the sine. So let's just see how this goes. I'll make my u substitution for x plus pi over 3. Then when we take the derivative, we're just going to have du equal to dx. And while I'm at it, I'll just get a value for x to plug in here. So x is going to be just u minus pi over 3. So now we'll just go ahead with this. We're going to have sine u minus pi over 3 in the numerator. This is just going to become cosine of u right here. And then dx is just du, so that's nice. But now I avoided the angle addition formula for cosine, but now we need to use angle difference on sine. So let's just look at the angle difference identity for sine. Okay, so we have our formula to use over here to the right. And so in this case, our u will be our a value and our b value is just going to be pi over 3. So what I'll do is just rewrite the numerator using this format. So we're going to have sine of u here, cosine pi over 3. And then we're going to have minus sine pi over 3 times cosine u. And this is going to be all over cosine of u. But now cosine pi over 3 and sine pi over 3, those are both constant values. Sine at pi over 3 is going to be just square root of 3 over 2. Cosine at pi over 3 is going to be 1/2. So what I can do is split this integral up on the minus sign, and then for the first one, we'll take this half and we'll bring it out front of the integral. Then we're going to have just sine of u over cosine u. I can write that as tan of u. Then for the second integral, we can take minus square root of 3 over 2 and bring that out front. And then in the integral, we're going to have cosine over cosine, but that's just 1, so we'll integrate 1 du. And so now we can just go ahead and integrate. We'll have our 1/2. Integral of tan u is going to be natural log absolute value secant u. And then here we're going to have a minus square root of 3 over 2. Integral of 1 is just going to give me a u. But actually, I think I'm going to write this in the other form. The reciprocal of secant is cosine, so we can write this. I can write this as cosine of u and bring a minus sign out front. And then we just need to back substitute in order to finish this off. So let's see what happens. We're going to have minus 1/2 natural log absolute value cosine of x plus pi over 3 here. Then we're going to have minus square root of 3 over 2. X times pi over 3, but now if I distribute in square root of 3 over 2 to pi over 3, we get a constant value, but that's just going to be absorbed in the constant, so I'm going to leave that off, and we'll just circle it, and that's it. Okay, good problem from UNSW CPMS 2023. Thanks everyone for watching. Have a good day.